Good afternoon, everyone. Welcome back. Welcome back, दोस्तों. How was your physics exam? Quickly write down in the chat box. Good afternoon. Quickly, first write down in the chat box. Am I clearly visible and audible? Quick, दोस्तों. We are back with physics analysis, physics board exam analysis. Quick, दोस्तों. As you can see, this is, by the way, this is set 1. This is set 1. Hi everyone, hi. But why are you saying that your paper was not good? I think paper was easy. Correct me if I'm wrong. 5 marks out of syllabus nahi in set 2. All right, okay, we'll discuss the paper. I'll solve each and every MCQ, okay, so that you can match your answers. We'll discuss these. Whatever I have seen in paper was easy. All right. So if you are saying that paper was difficult, please write down in which part you faced the difficulty. According to me, paper was easy. Right, Yashi, paper, I think paper was easy. Set 3 hai. This is set 3. I think set 3 is this one. This is set 2. This is set 3. Let me check once, dosto. This is set 3 yaar, hai na? I've got every paper. Whole paper was hard? Nahi, I don't think whole paper was hard. I don't think so. I'll prove it to you. Paper was not at all hard, but theek hai, it's all good. Whatever you have done. Now, our today's class motive is not to prove you wrong, not to say that, oh, see, the paper was easy. Actually, in my one-shot marathon, we have covered many topics. I'm going to let you know. But now, the motive of today's live session is so that you can actually check your answers, especially for those MCQ. Other than that, you already know all the derivations and all of those things. So main concern is for MCQ. Then quickly we are going to talk about another subject, right? I'm going to share schedule and details for the another subject also. You are going to find everything on this channel. But for now, let's start to discuss. Set 2 was hard. Set 1 was tough. So we have got all types of students who are saying that each set is hard. Is that clear? Chalo, let's begin. Let's begin to discuss. Let's begin to discuss, my dear dosto, the paper. This is set A, section A, question number 1. I would say question number 1 is actually what we can say. I'll not say that it is really easy. I'll not say that you will be able to do it in 10 seconds and you will move on. But not at all difficult, right? Set 1 was the toughest, so we'll start with set 1. All right, chalo, quickly let's see what the question is saying. Question is saying 2 horizontal plates separated by a distance of 1 centimeter. So we have got 2 horizontal plates. We have got 2 horizontal plates, something like this. And the separation between these plates is 1 centimeter. So for me, this is actually 1 into 10 to the power minus 2 meter. Right? And they are saying that are arranged one above the other, a particle of mass 5 milligram and charge 2 watt nanocoulomb is released in air between the plates. The potential difference that should be applied so that the plates, so that the particle remains suspended between them. ठीक है? For the first question, I'll not say that this is an easy one, but I'll solve it. So let's suppose this is a charged particle. We know that mg will act downward. By the way, dosto, mg is given as 5 milligram. Now, one of my student actually told me, sir, you know what I did? I actually wrote this thing as mg and by mistake, I wrote it as 5 milligram times 10. So this is one of the mistake that my student has told me, sir, this is the mistake I have done it. I knew how I am going to solve it, but still, in that exam pressure, the first question I did. So this is actually milligram, dosto. Okay, this is milligram. So first we'll convert it into gram. So we'll write 10 to the power minus 3 gram and then 10 to the power minus 3 kilogram. So this would become 10 to the power minus 6 kilogram. Is that clear? Quickly tell me in the chat box. Is it clear? Acha, if we want to balance this out, mg, we'll have to apply another force over here, and this force will be electrostatics force. that is Q into E, and E can be further written as, दोस्तों, E can be actually written as potential difference divided by D. Everything's clear. We know each and everything. What we need to find it out? We need to find it out V. So we'll simply write QV divided by D is actually equals to mg, and V will be actually equals to mass. So mass can be written, mg can be written as, दोस्तों, 5 into 10 to the power minus 5 times D. D is nothing but 10 to the power minus 2. 10 to the power minus 2 divided by charge. Charge is 2 nanocoulomb. So 2 into 10 to the power minus 9 multiplied by nothing here. Multiplied by nothing. I don't think so. We don't have anything over here. So that's it. Quickly write down in the chat box. Is it clear? Is it clear? Everything's fine. MGD divided by Q. Absolutely good. Madhusudan, welcome back. Did you, did you attempt this paper? So this is going to be, दोस्तों, we have got 9 over here, we have got 7 over here. So this would become 9 minus 7. That means 2. And this is actually 2.5. So this will become around 250 volts. So option A is going to be correct. Quickly write down in the chat box. Quick. Quickly write down in the chat box. What was your answer for this one? Dosto, quick, be quick. See, even if you have opted, even you have taken the value of G as 9.8, fine. You will get your answer somewhere in between 250 only, right? So that was not a problem. Can we move to the next question? Second question looks like a Wheatstone bridge. We know that they will give us a balanced Wheatstone bridge. They can't give us unbalanced Wheatstone bridge because it is not in course. Is that clear? So it has to be a Wheatstone bridge and a balanced one. Is that clear? So acha, quickly tell me, this 4 and this 2 are in series combination. So this will become, I can simply write over here as 6 ohm. Acha, 6 ohm and 3 ohm are in parallel combination. So this resistance will become, by the way, I'm going to draw an equivalent circuit also over here. Something like this. So this 6 and this 3 are in parallel. So that means 3 times 6 divided by 9. 3, that means 2. So this is going to be 2 ohm. This is going to be 2 ohm. Acha, fine. This 3 ohm and this 6 ohm are again in series. So this will become 9 ohm. So this 18 and this 9 will again become in parallel. So that means this is going to be 9 times 18 divided by 27. So this will be times 3. And this will be 9, 3. So 6. So this is going to be 6 ohm. Please check. Quick. Acha, this is 4 and this is 12. So that this means this is in balanced Wheatstone bridge. 2 by 4 is actually equals to 6 by 12. That means we can remove this thing. So that means this will become 2 plus 6 is 8, and this will become 16. So we have got two resistances. Finally, we have got two resistances, dosto. One is over there, we have got 8 ohm, and over here we have got 16 ohm. So again, we are going to do the same thing. 16 times 8 divided by 24. So times 4, 6, 2, 3. That means this will be 16 by 3. That means option C. So I'll not say that these were questions which you can do it in matter of seconds, but still everything was from course. You could have expected this type of questions. Okay? Nothing bad. See, now what you can actually what you can learn from your physics exam is that take your previous year questions seriously. Take all of those, I mean those one shot lectures that all the faculties are taking, right, from physics wala. I mean those things are really beneficial. We can see that, and I'll prove it to you that from my own one shot videos how many questions have been directly came. Although we have talked about all of these questions. If you remember, we have also talked about this particular type of question in our one shot video. Chalo, fine, let's move on for now. Question number 3. Now again, please understand that they'll not ask you to write down the formula of magnetic flux as it is here. Huh? can we imagine something na? Can we actually expect ki they are not going to ask us that what is the formula for magnetic flux? They'll not ask this simple question. What they are saying that a rectangular coil of area A is kept in a uniform magnetic field B such that the plane of the coil makes an angle alpha with magnetic field. What do we mean by these things? What do you mean by plane? Acha, let's have a look at this diagram. Let's suppose this is a area, this is a conductor, okay? And if this is the conductor and this is the magnetic field, I'm going to call that this is the plane of the conductor. This is the plane of the conductor, right? This is the plane of the conductor, and plane of the conductor is perpendicular to magnetic field. So of course the area vector will become parallel to the magnetic field. By this is magnetic field and this is the plane. This is the plane. So area vector will become parallel to magnetic field. Now they are saying that area vector, the plane is making an angle, plane of the coil makes an angle alpha with the magnetic field, which basically means that if you are going to talk about flux which is BA cos theta, now this theta will become pi by 2 minus alpha. So this will become BA cos pi by 2 minus alpha, which will be your sine alpha. Everything's clear? Sir, please tell the passing mark scheme. Well, passing mark scheme does not change here. This is not an competitive exam. It will remain 33%. And let's not talk about passing. You all will get good marks. Okay? You all will get good marks. Chalo, let's move on. Which set is difficult? We can actually we can compare the difficulty level. Although you won't find that a particular set is extremely difficult. That will not happen. That has not happened in past also. Okay? Can we move on? Everything's clear till this point. Do you have any doubt? If you have any confusion, please write down in the chat box. If you have any confusion, dosto, please write down in the chat box. Okay? I'm moving on. An alternating current is given by I equals to I naught 100 pi t. The least time the current takes to decrease from its maximum value to 0 will be. See, this is also again, I'll say that it is an easy one. They have simply given the function of current in the form of cos. And we know that for cos graphs look something like this. Okay? This is the maximum value and this is the first time it will get minimum. It will get 0 at pi by 2 angle. Is it clear, dosto? So that means whatever this angle is, just equate it to pi by 2. Just equate it to pi by 2. So 100 pi into small t should be actually equals to pi by 2. This implies that small t equals to pi can be cancelled out. This will be 1 upon 200 seconds. So 1 upon 200 seconds is the answer. Let me know if you have any confusion. Quick. See, out of the students who are, the students who are able to talk with me, they also told me that set 1, they find it, they as far as they could actually discuss the sets, they told me that set 1 was relatively tougher, but still we'll compare it, so don't worry. Let's now move on. A capacitor and an inductor. Acha, one insight from my side. What I think is, personally, MCQ was not easy. It was moderate. These questions, I am not going to say these questions are easy. Why? Because easy basically means a question something like this can be considered as easy. This can be considered as easy. But this is again, we can expect that the students who actually know the concept will make a mistake. This is also easy, but still, you need to actually do calculations multiple times. Now, chalo, let's move on. This question is saying a capacitor and an inductor are connected in series and across an AC source of a voltage variable frequency. The frequency is increased continuously. The nature of the circuit before and after the resonance will be. Acha, we all know that resonance. What do we mean by resonance? We have been talking about resonance in LCR circuit. Okay? In LCR circuit. But right now what's happening is they are saying that we have got an LC circuit. So in LC circuit, if they are saying that we have got resonance, which means that XL will be equals to XC. Acha, what do you mean by XL? XL is actually equals to omega L, or can be written as 2 pi F into L. Xc can be written as 1 upon omega c or 1 upon 2 pi f into c, right? So if you are going to talk about, I'll draw a graph for you for this one. Okay, let's say we have got frequency over here and we have got two graphs, dosto. Instead of drawing one graph, I'll draw two graphs. One is for inductive reactance. So for inductive reactance, the graph would look something like this. By XL will be directly proportional to frequency, right? XL will be directly proportional to frequency. And if I'm going to talk about another graph, which is XC, XC is inversely proportional to frequency. So that means the graph would look something like this. Hopefully you can see this color as well. Acha, everything is clearly visible now. Let me know in the chat box. I'll use another pen. This is going to be the graph for XC. Okay, XC is inversely proportional to frequency. At this point, my dear dosto, at this point we have got the resonance frequency. Everything's clear? So you tell me now, they are saying कि the nature of the circuit before and after resonance. So this is resonance. Before resonance, we can see that the nature of the graph is actually capacitive, and after resonance we can see that nature of the graph is inductive. So capacitive then inductive respectively. That means option C. Let me know in the chat box if you have any doubt. Quick. Is it all good? Come on. Fine. I've also proved the answer. Now let's move on. A metal rod of 50 centimeter is held vertically and moved with a velocity of 10 meter per second towards east the horizontal component. Now somebody might say, sir, horizontal component of Earth's magnetic field is not in our course. So why have they given us something like this? Hai na? But can you please note one thing, that although this particular thing is not in our course, but still you could have expected that they will just give you something related with magnetic field of Earth. That's what they have done, nothing else. So you just have to use the formula. The EMF induced will be BVL, and magnetic field is given as 0.4 Gauss. So 0.4 times 10 to the power minus 4 Tesla. And you don't have to write T over here, but it will be in SI unit. Now this is something a student might forget, right? So times velocity was 10, length is again 50 centimeter, so that means 0.5. Everything's clear? We can cancel out one of the point over here, then this will become 20. So 2 into 10 to the power minus 4. Is it fine? I can rewrite this thing as 0.2 millivolt. So 0.2 millivolt should be the answer. Quick. Set 3 please. Set 3 most tough. Bhai, we'll have a look at set 3 also. Set 3 is over here. This is set 2. This is set 3. We'll have a look at set 3 also. But first, let's cover first set. Everything's cool? Clear? Now let's move on to the next question. Next question is saying dimensions of self-inductance. Now everyone was saying, I have also been personally saying that please remember the dimensional formula, at least remember how to solve them as quick as possible. So when you are going to talk about self-inductance, we know that we can quickly write it down using half Li square instead of using any other formula, right? Because dimensions of energy can be found out quickest. So L will have the dimensions of U divided by I square, and energy is nothing but force times displacement. Force is M L2 T minus 2 and A minus 2. That's it. This should be the time taken by you for a question like this, right? Got it? So M L2 T minus 2 A minus 2, that means option A. Moving on. The frequency of the photon. Now this is a calculation based. I'll expect you to do it. Energy can be written as H times nu. So nu will be written as energy. Energy was given as 1.326 times 10 to the power. Acha, This is an electron volt, na? So let's convert it into joules. So we'll have to multiply it with the charge of an electron. Minus 19, this becomes in joules, divided by H. H is 6.626 into 10 to the power minus 34. Come on dosto, quickly tell me, is everything clear? Acha, can I cancel out these points? By the way, if I'll also write, this thing will become 20 minus 20, this thing will become 14. So my answer should be something into 10 to the power 14, right? So this is 1326 times 16 divided by 6626. I think when I solved it, it came out to be option B. Just now when I solved it, it came out to be option B. Is it clear? Quickly tell me in the chat box if you got this answer. Quick. Correct? Arey bhai, almost the set is going to be same. Whatever the differences, I'm going to let you know. So don't worry, don't spam. We'll solve it. I've started chronologically, A, B, C. So don't worry. Germanium crystal. If you have any doubt, please write down in the chat box. Okay? Don't spam. Germanium crystal is doped at room temperature with minute quantity of boron. What do you mean by boron? Boron is bhaiya group 13 element, na? This is from 13th group. So 13th group basically means this is trivalent. So trivalent basically means that when you are going to have your final doped semiconductor, this is going to be a p type, which means that this will have majority of holes, right? So the charge carriers in the doped will have holes with few electrons. So option C is absolutely correct. Don't write only holes. All right, it will have majority of charge carriers as whole, but minority will be electrons will have its minority shares. Out of the 4 options given, in which transition will the emitted photon have the maximum wavelength? अच्छा देखो, अभी इसमें you will have to actually calculate it, but there is also a trick behind it. Sir, set 1 करा दो अभी, और what are we doing? This is set 1 ना, this is set 1. You are spamming for set 1 when we are doing set 1. Yeah, I'll have to take care of spammers here. Chalo, filal, let's move on. So when you are going to talk about these types of questions, na, what you will have to actually check is, spamming ho rahi hai. You will have to actually check 2 things. You know how to write the formula. E can be written as hc by lambda. So the transition in which delta E will be minimum, in that case lambda will be maximum, right? So although now we have got some, see, this can't be our answer because this will have maximum energy out of these 4, है ना? Because this is from 3 to 1, so this won't be as our answer. You will have to check for 4 and 3, 3 and 2, and 2 and 1. Right, and use your normal formula here, minus 13.6 times 1 upon 3 square minus 1 upon 4 square. This is going to be for option A. For option B, same, 1 upon 1 square minus 1 upon 2 square, and when I checked it, the option was option A, right? This is similar to set 2, but set, this was, acha, theek hai, let me, set 1 nahi hai ye. This is not set 1, this is set 1, I think. Sarita, can you please confirm? Set 1 है, please please block. If people are unnecessary spamming, then we have got no option. A PN junction is forward biased. As a result, both potential barrier height and width of the depletion layer will decrease. First option is absolutely correct, right? Because what happens in a PN junction, you have got depletion layer over here, which is basically a region devoid of any free charges, right? So in this region, let's suppose this is P type, this is N type, we'll have negative charges over here, we'll have positive charges over here. So electric field will be in this direction from positive to negative, and when you connect P type with positive terminal, N type with negative terminal, you set up electric field in this direction. So when you increase this electric field, this depletion layer begins to decrease, and so potential barrier. So option A will be absolutely correct. Correct? Everything's clear? Set 1, we are solving set 1 isotones. Quick, dosto. Any more doubts? Sir, set 1 is tough. Set 1 is tough. ठीक है. Set 1 is tough. Fine, no problem. So this one will have same neutron number but different proton number. That means different atomic number. So option C will be correct. Now this was easy. Acha, now let's move to assertion reasoning. See, I am again and again repeating, the first section A was not easy. I'm quoting it. You can quote me. This is, I'm not going to also say that this was really difficult, but it was not at all easy, right? We'll see. Let's suppose that a charged particle is moving with a velocity in xy plane. Let's take an example for this assertion reasoning. Making an angle, that means this is a case for an when the particle enters obliquely in magnetic region with x-axis, if a uniform magnetic field is applied in the region along y-axis. So, I mean, most of the time, even when I actually, and by the way, this was a topic, one of the student in my marathon said, sir, please explain helical path also. So I did that, right? Now the students who were able to actually got the concept will be able to do it. Why? Because generally in my class also I always say that this is magnetic field, this is magnetic field, and this is how the particle is entering in this magnetic field. In this way the particle is entering into the magnetic field, right? But now what they have said is, the question is quoting that you have got magnetic field in y direction. Magnetic field is applied in y direction. So this is the direction in which magnetic field has been applied, right? A particle will move in helical path, and a charged particle is in xy plane making an angle theta with the x-axis. So this is, let's suppose this is x-axis, dosto. This is x-axis. This is magnetic field. So particle will be thrown with some velocity v at an angle of theta with the x-axis. So it will have two components, right? One component will be along this, which will be v sine theta. One component will be along this, which will be v cos theta. Is it clear? Now please understand, the direction of the direction will be changed because of this component of velocity. This will have no change because this component of velocity is along the magnetic field, right? So this particle will actually move something like this. This is going to be the helical path. Usually we saw helical path something like this, na? Are you getting it? So the helical path, the particle will move in a helical path with its axis parallel to x-axis. So now you can tell me, quick. Paper was, I'll say one thing, that paper was actually, MCQ portion was moderate to slight difficult, and the theoretical portion is easy. All right, got it. Someone has come up with Alak sir's name. So quite daring. So now see again. So this is what it is. Please compare this diagram with the diagram that I have actually explained you in my marathon class. In these questions, magnetic field was something like this. We used to throw a particle in this direction. So this will have, we have thrown the particle in this direction. We used to throw the particle in this direction. So velocity became something like v sine theta and v cos theta. And because of this velocity, the particle used to move in this direction. And because of this component, the particle used to move in circular path, right? So if this is the motion of circular path, this will be the axis of body. But now the axis has become the x-axis. So it will not be parallel to x-axis, it will be parallel to y-axis. The direction of magnetic force acting on the charged particle moving in magnetic field is along the velocity. This is also wrong. This is also wrong. Why? Because magnetic force is actually perpendicular. is perpendicular to the velocity, not along it. All right, good, good, good. Can we move on? Next, a ray of light is incident again from the marathon, from previous, this question is from PYQ. This question is from PYQ. We can see that they are saying a ray of light is incident normally on a face of prisms. So let me make the diagram somewhere over here on this. Okay, I'll have to find some space. Can I remove this diagram, doston? Hopefully everything is clear with this diagram. Everything's clear, na? They are saying, let's suppose we have got a prism something like this, right? And a ray of light is passing in this direction. Okay? Passing in this direction. And we have drawn many diagrams like this from the previous year, section. A ray of light is incident normally on the face of prism. The emergent ray will graze along the opposite face of the prism when the critical angle of glass air is equal to the angle of prism. So let's suppose this is an equilateral prism. Okay? Let's suppose this angle is 60 degree. Or you can consider any angle. By the way, this is 90 degree, so this angle is going to be 30 degree. So this angle will become 60 degree. Right? This angle will become 60 degree. Acha, by the way, this will depend upon what is the refractive index of the outer medium, that is this medium, and what is the refractive index of glass. Is it clear? Only then we can commit something, na, ki TIR will only happen when angle of incidence is greater than the critical angle. Or if it is equals to critical angle, we would say that it will graze the path. Is it clear? Quickly write down in the chat box, is it clear? This will only happen, this will only graze the path when we have the information of refractive index, right? So the question was saying, a ray of light is incident normally on the face of prism. The emergent ray will graze along the opposite face of the prism when the critical angle at glass air. Acha, they have said glass air interface. So glass can be considered as, refractive index can be considered as we can consider it to be 3/2. Interface is equal to the angle of prism. So for glass air, this is absolutely true. This is absolutely true. But the refractive index of a prism depends upon the angle of the prism. This is false. It depends on the refractive index. It depends on the refractive index. Quick. Set 1, we are doing set 1. EM waves do not require material medium for propagation. This is absolutely true. Reason, EM waves are transverse waves. This is also true, but this is not a correct explanation. Not a correct explanation. What is the reason behind it? Bhai, it does not require material medium for propagation because it's a self-sustaining wave. Na? It is not created by oscillating particles. So we do not require the material medium for this. So this is not a correct explanation. The minimum negative potential applied to the anode in a photoelectric experiment at which photocurrent becomes 0 is called cutoff voltage or stopping potential. This is absolutely true. The threshold frequency for a metal is the minimum frequency of incident radiation below which emission of photoelectrons does not take place. This is also true, but again, this is not the correct explanation. So this is true. This is also true, but not correct explanation. Done? Quick. Tell me quickly in the chat box. Is it all good? I have explained the section 1 completely. Explained the section 1 completely. Now we'll have a look at section B because for solving out for finding answers for section B is not difficult. You are going to get these answers in your notes, in your what you can say, in your books and all, on internet also, right? Sir, you will be taking class tomorrow. I'll be taking class tomorrow, Madhusudan. Today we rescheduled again Yakin batch. Sorry for that, just for this. Hopefully you can all understand. Let's move on. Acha, next question is saying a cell of EMF I'm going to just look at the questions and then we are going to move on. Not now, obviously, for those students who are preparing for only board, now board has over. Now whether your next goal is JEE mains, second attempt or NEET, let's begin that preparation, right? You're going to find each and everything on this channel. So let's start that preparation right away, or let's say after your board exams gets over. Okay, we are just going through it, analyzing what's going to be the correct answers for this. A cell of EMF E and internal resistance. This is from PYQ. Okay, this is from PYQ. I can assure you that. Show that graphically the variation of, see, for this one na, terminal potential difference E minus IR, and I can be written as actually net EMF divided by R plus R, and then just solve it down. If you will solve it down now, you will actually get E times capital R divided by R plus R. Finally, I can actually rewrite this thing as E upon 1 plus E upon 1 plus small r upon R. So this is the finally formula from which you can draw the graph, and one of the graph will look something like this, where you have got R and you have got V. Okay, hopefully you can do it. I have explained this is the terminal voltage, was covered in the class using mirror equation and formula. Using the mirror equation and formula of magnetic, deduce the virtual image produced by the convex mirror is always diminished. Very easy. Okay, I'm not going to say this. Now see, that's what I was saying. Section A was moderate to difficult. After section A, nothing is difficult here. Okay, I can't say that these things are difficult. Write two differences in the patterns of double slit experiment and single slit diffraction experiment. Whenever we talked about YDAC, we discussed this thing, that intensities of maximas in double slit experiment was same all over, right? It was 4I, and in diffraction, the central maxima had the maximum intensity, and then intensity goes on decreasing, right? Light waves from two pinholes illuminated by sodium lamps. You can see this again from my one shot video. We discussed. Acha, by the way, yesterday I took a model test paper, and I used the same question over there also, that two sodium lamps do not produce interference patterns. Explain why. Because they will never remain in phase. They will never have a fixed phase relationship between themselves, right? They will run out of phase. Alright, this was the correct answer. Draw energy band diagrams for N-type and P-type semiconductors at temperature greater than 0 Kelvin. Show that the donor acceptor energy levels with order to difference. You have to draw the diagram that you have learnt in band theory. Is it clear? Right? Easy peasy. Briefly explain how energy is produced in stars. Nuclear fusion, you have to give two examples. One, you can take the examples that two hydrogen atoms fuse to make an helium, right? Another you can actually give for carbon. Carbon 13 isotope is also fused and it makes nitrogen. So you can use the second example as that. So this was slightly out of the box, but we have got examples in NCERT. Three cells A, B, C, EMF. So you have to use the formula of parallel combination. Parallel combination of three cells. Do you remember? E1 upon R1 plus E2 upon R2 plus E3 upon R3 divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3. You had to use this formula. Got it? Got it, got it, got it. Done. Moving on. Write Biot-Savart's law again. I explained this in my our one-shot marathon, boards marathon, which I took I think 3 days ago. I explained Biot-Savart's law. Two identical circular coils, each of radius r, carrying current I and √3 respectively, are placed concentrically in XY and YZ plane. They are saying that one of the thing is kept something like this in XY plane. In XY plane and YZ plane, right? So YZ plane would basically mean something like this, and this is YZ plane, and XY plane, I can basically, they both are going to be perpendicular. Okay, find out the direction of net magnetic field at their common center. So net magnetic field at their common center will be found out by mu naught divided by 2r. R is going to be the radius. We have done Biot-Savart's law. A rectangular loop of sides L and B carries current. Write down the magnetic moment. How simple it is. Magnetic moment is just I into A. I into A. Direction will be found out using right hand rule. We have done it in class. Torque is equals to M cross B is free to all of these. I mean, can you please check from that board's marathon class till now, whatever derivation are we getting now, I have explained those derivations in that class. Okay, please check by yourself. Please check by yourself. This derivation also I actually explained both the cases, the specific case where torque is MB, just MB, and second case is MB sin theta. So I have proved that thing also. State Faraday's law again completed in the class. Now you tell me, is section B difficult? Section B could be far more difficult than this. I mean, CBSE never does this, that it has given, see, it has given one section C, sorry, it has given from section B. If I'll talk, section B has theoretical quotient, reasoning quotient. I've got just one small numerical over here, then derivation, then one small basic numerical, then again derivation. Again derivation, I would not call this as derivation, but this is again derivation. This is again a complete theoretical. Where are numericals? You have been always telling me, na sir, numericals is my weakest link. Okay? So where are numericals? Got it? Clear, clear, clear? By this is the paper that was given here. Differentiate between conduction current and displacement current. Conduction current is what? Is your normal dq by dt, and displacement current is because of changing electric field, right? Got it? Why are you saying this, bhai? I don't think we have got any problem with this set. Define work function. Line say we have got line of quotients as theoretical ones. Define work function, right? We have already covered it. It is the minimum energy required. It is a minimum energy which is required for a metal so that electrons can be emitted. Then you have got a stopping potential is 0.6 electron volt. Calculate the wavelength of the light used. Work function is 2.4 electron volt. How easy it is. You have to just use Einstein's equation over here. Then write the mathematical forms of postulates of Bohr's theory. I am not seeing numericals till this part, right? Till this part. Got it? Got it, got it, got it. Then you have got a theory portion on metallic conductors, which was, I think, similar to what we have seen in sample paper also. Consider two cylindrical conductors A and B made of same. You have to talk about mobility. Mobility is what, दोस्तों? Mobility is drift velocity divided by electric field. ठीक है? They are talking about electrons A and B. You can easily find out the drift velocity relation using the length and radius. That's it. ठीक है? Set 1. This was set 1, and I think you can see that after this we don't have any problem. I can't see any problem which was actually out of course. If you are talking about set 3, this was your set 3. This was set 3 which you have been talking about, and see I have got set 2 over here. Now tell me, many people are saying that sir ऐसा कोई paper ही नहीं आया था. What are you saying? This is set 3. And if we'll have a close look at the numericals at the section A over here, this is actually set 2. Sorry, this is set 2. If we'll have a close look at numericals over here, we have seen electric field E and electric potential at a point inside the charge of a hollow metallic sphere. By hollow metallic sphere basically means that inside of it there will be no electric field, and which would mean that minus dV by dr will be 0, which would further mean potential will be constant. So I think first question, if I'll compare question with question, so first question is really easy. This is a matter of 5 seconds. The first question of set A was not a matter of 5 seconds, right? Got it? So E is 0, V is actually constant. So again same, already solved it. Use use the formula of half Li square, right? I think it was ml2 t minus 2 a minus 2. Option D was, I think, correct for this one. Quickly tell me, bhai. Acha, for this one, in a circular loop of radius r, current I enters at point A, exits at point B. The value of magnetic field at center O is. Acha, you know what? If you have ever, I mean, this question is actually quite a what we can say a famous question when we talk about NEET and JEE and all. They should have actually mentioned that these wires are going to be of uniform, are going to be uniform. These are not different material or different cross section, and if they have not specified it, we'll assume it. Okay, what will happen if current I will come, current will distribute, it will become I1, and next current is going to be I2. Because of this I1 current, magnetic field will be actually cross B1, and because of this magnetic field will be dot. And we always write a note that this magnetic field, whatever this this section is, this is basically 90 and this is going to be 270, that is 3/4. So a quarter circle and 3/4 of circle, whatever is this, even if it was a 60 degree, this always comes out to be 1. The magnitude always comes out to be 1. And because they have got opposite directions, and this is going to be 0. Is it all good? Is it all good? Quick. Right? Done? The frequency of a photon, same. E equals to h times nu equals to E by h. Just convert E into joules. A metal rod, same. So till now, what I am seeing is set A was difficult till now. Till now, I am saying set A was difficult. This is set B. Again saying this is set B. Germanium, same. Already solved it. Same. 16/3, same. Same as set A. अरे भाई, this is set 2 यार. जब I was solving set 1, तब you were saying that sir it is not set 1. Now I am solving set 2. हाँ, क्या हो गया फिजिक्स का पेपर देखे आपको? सेम. This was, I think, capacitive and inductive, and I also solved it using same. Same means I have already solved all of these questions in set A. If you want to have these solutions, please drag this video by half an hour. You will get all of the solutions. ठीक है? ठीक है. Easy, you can do it. You have the mass numbers of two nuclei, A and B are 27 and 64. The ratio of their radii will be very easy peasy. Okay, very easy. I mean, what I can say is that this question is easier what we have seen in, or slightly same that what we have seen in set A. Set A was about isotones. This is about ratio of RA and RB. Acha, isotones, we have got isotones over here also. Then PN junction diode is forward bias, as a result same as set A. Quickly tell me if you have any doubt till this point. This is set 2. This is set 2, na? This is set 2. $55.72. This is set 2. 10th. Section D. We are coming to section D. Don't worry. Same question. Same as set A. Why you have to send me question paper, my dear dost? maximum number of questions are going to be same, but let me now check if we have got more sets over here. Let me check it. इतने we have got lots of derivation over here. Please. Now let's move to next. Charge particle same, minimum anode same, threshold. All of the what we can say, these questions were same. All of the assertion based questions were same. 5573. This is 55. This is 5572. This one is 5573. That's what I have till now. If I'll get more papers, I'll come live for you. Okay. See, I started this session at 2:45. Your exam got over at 1:30. I was able to get 3 sets. I started the session with these one. All right. Done. So let me see a set 3 over here. Now, if you'll see, these two are in parallel. So parallel would basically mean C equivalent will be 12 plus 8, that is 20. And then you have got 20. So this will become 20 and 20, this will become 10. So 1 upon 10 plus 1 upon 4, that means 40 divided by 14. I mean, just a second. We have got, this is 20. Absolutely. They are finding the charge. So first find C equivalent. And then we have to find out the charge. The charge on the right plate of the charge on the left plate is 50 microcoulomb. Left plate, that means this one has got charge Q, that is of minus 50 microcoulomb, and on the right plate 12. So we have to find out at this particular thing. So do one thing. We found out the equivalent capacitance of this one as 20 na. So 20 microfarad times charge is 50. Charge is 50. So you please find out what potential is going to be. So V will be Q by C. So 50 divided by 20. So this is going to be 2.5, and as soon as you know what 2.5 is, just find out the charge in this specific one. Quickly write down in the chat box. So for the first question, set A was the hardest, then we have got set 3, and then we have got set 2. Set 2 was the easiest one. Got it? Done? Same, germanium crystal is doped. Now you please tell me, you haven't seen these questions in your set. All of those students who are saying that, sir, I've got different set, have you not seen these problems? I think majority of the questions are going to be same, na? How can it be different? Quick, tell me, have you not seen these questions? ठीक है, तो I think I have solved this set, which is of I'll tell you. We have today solved this particular thing, and as soon as I'll get more sets, I'll come live for those also, right? By the way, maximum number of questions I have already discussed. You'll find maximum number of questions have been discussed. Now, if you were able to match some of the questions from this set, good. If not, I'll come up live with those sets also, right? Got it? So according to me, I'll say the last words. According to me, the paper was easy. It was not at all difficult. I'll also not say it was moderate. As far as I've seen these 3 sets, it was quite easy. Okay? All right, so that will be all. I'll be in touch with you today. We are going to discuss more papers. I'll also make some short videos to explain which paper was slightly more difficult. Okay, that will be all. Thank you so much. Please prepare for your next exam. You will have your chemistry marathons running on this channel. So stay updated. One shot marathons model test paper, and please note, as far as this paper is concerned, there were many questions which were directly came from the one shot videos that I took, the model test paper that I brought in front of you, right? That will be all. Thank you so much. I'll come live as I'll get new papers. Chalo, bye bye. Thank you so much.